and welcome back to the channel. It's great to see you all again. I'm Mr. Sensible. Just make yourself at home, you know the drill. Today we're going to have a look at a YouTube user called ThePottersClay. He seems to have a real problem with the moon shots and other space launches when the capsules have returned to the sea, that there's not billowing great clouds of steam. Before we go into that though, a quick thank you to my wonderful patrons. My most excellent patrons: Andrew Smith, Bernard Godfrey, David Cooley, Elizabeth Schneider, Frank Kelly, Frederick Sigard, Gary Tompkins, John Calvin Hobbs, Mick Farnham, Mitch Goldstein, Poison Toad, Roy Fraser, Simon D, Steve Pleggy, Sisyphus and Touchpad. Thank you all so very much. Right, Mr. ThePottersClay, get on with it. Show us your stuff. Roll VT. Okay, so ThePottersClay, you're going to start off with a question for our friends at NASA. Well, I'm glad you get on so well. That's really nice. Let's go.
The command module would be traveling at 25,000 miles per hour when it hit the upper atmosphere.
If you travel down the highway, you're traveling at 60 miles per hour. You're traveling at 88 feet per second. We're coming in at 36,000 feet per second.
It smashes into the atmosphere. It doesn't fly as much as smash.
Straight away, big scary numbers. I just know that's going to scare the bejesus out of ThePottersClay. Let's see what happens.
To protect the capsule, the engineers had built the largest heat shield ever.
That is important. Don't forget it. The largest heat shield ever. And look outside the window. I wonder what that could be. We'll come back to that.
Re-entering the Earth's atmosphere is dangerous because of the enormous heat it causes.
And what is that streaming off behind the capsule? Remember that. We'll come back to that, ThePottersClay, as well.
The heat shield protects the command module for several minutes as it passes through the atmosphere.
And they've already told us the heat shield protects the capsule as it passes through the atmosphere.
Down below, an aircraft carrier waits for the astronauts' arrival. Once we get about 2 miles above the surface...
2 miles above the surface. Remember that, ThePottersClay.
Parachutes are deployed to slow us down even more. The hard part is over. Now we just enjoy the ride. The final part of every mission, Splashdown.
No. You're not going to do this, are you? You are, aren't you? Okay. Yes, you get some steam. Oh, look at that. That water's boiling off, giving us the steam. Now that's a good idea. A grilled cheese sandwich. Are you offering? Look, let's get back to your griddle pan. When you first put water on, it instantly boiled and steamed away. Now it seems to be taking a little longer. I wonder why. Definitely struggling now. Perhaps it's cooled off already. I get the idea. You're an idiot. Oh yes, let's.
Stand by for a hard impact. Over now, over. Roger.
There was a mighty big splash, but you seem to be right. There are not billowing great clouds of steam.
It's a fantastic shot. Landing velocity on 2 chutes is 28 feet per second, or 32 feet per second versus 28 feet on 3 chutes.
28 feet per second. That's a lot slower than when he was, whatever it was, 38,000 or 33,000 feet per minute. A lot slower.
It was in stable 1 condition. It looked like a hard impact, but the spacecraft appears to be all right. It hasn't turned over.
Ooh, you're right. Test flight splashdown. Now I don't know. Was that a launch? Was that a re-entry from space or just up high? I don't know. Who said it's extremely hot? Just you. Well, as I said, I don't know exactly what this test was, whether it was a launch into orbit and back again, or just sort of, you know, up a few miles and back down again. Who knows? Ah, curiosity. Good thing to have. How hot? How hot indeed do they get when re-entering? Let's find out. Ah, here we go. Here we go indeed. Right. A capsule can get up to 1480 degrees centigrade. I notice you circle the 2,700 Fahrenheit because that's a bigger number. But that is mighty hot. Yeah. 2,700 Fahrenheit as it descends through the Earth's atmosphere. Did you read the next bloody sentence? All this heat has to be directed away. You've cut off the rest, but the next line. Capsules are typically coated with a material that melts and then vaporizes. That's called ablation. It may seem counterproductive, but this vaporization takes heat away from the capsule. My, that sounds like a good thing to have as a heat shield. Carry on. Yeah, go on, keep highlighting, keep... Oh, you're going to stop there. I wonder why. Cherry picking much? And what's more, cherry picking without understanding? Crazy hot. Oh, so I didn't realise it was crazy hot. Sorry. I hate fun facts. Whenever people come out with these fun facts, it's usually something stupid and incorrect. Let's see if you get this one correct. Okay, lava 1600 to 21 Fahrenheit, and it steams like crazy. Yes, because it's between 1600 and 21 degrees Fahrenheit as it's hitting the bloody water. And it's a constant stream of material at 1600 to 21 Fahrenheit. Remember your griddle pan thing? You added some water and it soon started to cool off that piece of metal. One of those capsules, I don't know how much one of those weighs, let's say a ton or two, I don't know. It's dropped into the whole bloody ocean. Any heat that there is still in that capsule is going to get dissipated pretty quickly. And we still haven't established that it was anywhere near 1600 or 2100 degrees Fahrenheit when it hit the water. Tell you what. How does a 2700 degree metal pyramid fall out of the sky? That'll be gravity, mate. And look at that picture, your CGI picture. Can you see all that streaming fiery stuff? Do you know what that is? That is heat shield. Ablative heat shield. The heat shield heats up due to the friction with the atmosphere because it's going so flipping fast. As it heats up, it melts, it vaporizes and blows past. carrying the heat away with it, because that's what an ablative heat shield does. It disperses and carries away the heat, so protecting that capsule. You can find all this out just by looking at Wiki or NASA or any one of 101 other websites. Because it's not that hot when it hits the water. We've established that it's a peak of 2,500 degrees or whatever. Yeah, it does get up to that as a peak, but all the time the heat shield is carting away that heat. All the time the capsule is slowing. The flight of the capsule through it, striking the air at speed, it heats up and then that's carried away by the heat shield. It's dissipated its heat, dissipated its speed, converting it to heat, and that heat is carried away. It's slowed down. We also saw that those parachutes are deployed about 2 miles high. It's quite chilly up there at 2 miles high, and by the time the parachutes are coming out, it'll only be going, I think, around 300 miles an hour, if I recall correctly. At that speed, it's not going to be generating heat. It's going to be cooling off. It's rushing through the air, which is also helping cart away heat. And what's more, the air at that height is rather cold, and it's several minutes of passing through cooling air before it reaches the sea, by which time the temperature is a lot less. That is why you don't get steam when it hits the water. Modern space vehicles are fitted with much more effective heat shields than earlier missions, such as the Apollo missions. Have a look at this.
So these are the L900 blocks, and as you can see, they're glowing hot in the middle. These tile blocks have some pretty cool properties. They're over 90% air, so they don't store a lot of energy, and air doesn't transfer energy very well. So they cool off pretty quickly. They also have, the silica fibers have low thermal conductivity, so while the inside of the tile is still 2,300 degrees, I can play with it because it's not transmitting any of that heat back to me. And I can stay here probably for a few minutes. So you can touch that.
This side?
Yeah, it's cool.
Oh yeah, this is...
It's completely cool to touch.
Oh my god.
Well, I hope you enjoyed that. Another bunch of flat-hard total failure. If you haven't already, please subscribe. Just hit Mini-Me down in the corner. Until next time, stay sensible.
Shut up and sit down.